Morning, Coach Primo here. AQR 5.3.2, second lesson of the day, Concentrations of Medicine. This is another example of piecewise functions. The bell ringer is, why do you believe some medical conditions require daily medications? Let's say, for example, allergies, high blood pressure, high cholesterol, and so on. You may think, hey, you can't just take, it's not a cure. It's actually, those medications they don't cure anything. They treat a symptom of the problem, which in my opinion is probably not a good thing. Big Pharma wants to make money, so the longer you take their medications, the more they can make money from you. So high blood pressure, instead of curing it, finding some way to stop somebody's blood pressure from being high by possibly telling them to try a different diet that might help their blood pressure, or stay away from certain things in their diet or certain activities that require them to have stressful situations, or include activities that might improve their blood pressure or cholesterol situation. Anyway, they require daily medication because the medication needs to be at a certain concentration in your blood. So that's a good way to look at it from that perspective. When taking medication daily, is it important to take the same amount of medicine each day? Yes, it is. Why? Because you need to maintain a certain amount of medication in your blood. What happens to medicine once it is swallowed? Well, your body takes the concentration that you're given, the dose, and it goes into the bloodstream, okay? Does the concentration of the medicine in the bloodstream change over time? And if so, how do you think it changes? Well, we have these cool things in our bodies called kidneys and liver, and they like to clean our blood. And so whenever we get any kind of chemicals in our blood that aren't supposed to be there, the kidneys and the liver, they function to actually clean your blood. And when they do, so if you get this medication, it'll treat and it'll help your body, it'll enhance it and make it treat some symptoms. But eventually, those medications need to get filtered out of the system because they're not natural. So they'll get brought out of your system through the kidneys. So that means the concentration will go down. So in order to maintain a certain level, if the concentration keeps getting lower and lower, it loses its effectiveness. We need to actually increase the amount of concentration in your blood. So we have to take another dose to increase that level. So great things. Please be sure to share any kind of great things you have with me so that I can share them with your fellow classmates here in your AQR class. All right, so have you ever taken a medication that your doctor warned you would not take effect for a few days? In this activity, you'll investigate why that is the case. Consider the allergy medicine, Sneeze Be Gone. Now, obviously, this is a fictitious medicine, but you'll get the idea. The regular dose is 20 milligrams. As with all medicines, the body gradually filters Sneeze Be Gone out of the bloodstream using the liver and the kidneys. The rate at which the medicine is filtered out is called the flush rate. Very important to understand the flush rate. That is the rate at which the medicine is filtered out of your bloodstream. For Sneeze Be Gone, the flush rate is 30%. That means, or in other words, in 24 hours after the pill is taken, 30% of the Sneeze Be Gone has flushed out of the body. If 30% of the Sneeze Be Gone is flushed out of the body, what percent of the Sneeze Be Gone remains? Well, that's pretty simple. It's the complement. It's 70%. 100% minus 30% is 70%. All right, we're going to use the calculator's recursion feature to fill in the table, assuming that an adult is taking 120 milligram dose per day. Look, I said dose. Remember, we lose 30% of the concentration, 70% remains. Then we add an additional 20 milligrams daily with a new dose. So I'm going to escape out of this. All the answers are here, but I really want to use my calculator online. So I'm going to do that real quick. It's in my TI-84 application. All right, I got my calculator up. I'm going to use my recursion feature to fill in the table. And we're assuming that an adult is taking 120 milligram dose per day. Let me go ahead and change that to the word dose, since I can do that. So we'll start. Remember, it loses 30% every day. So 70% remains. So let's take a look and see how that would work. First of all, we give a 20 milligram dose. Let's start with being in there. 20 milligrams. All right. Times 0.7 plus 20. Now we've just completed the first day. Its flush rate came out and we added 20. We got 34. Now, I'm going to take that amount, I'm going to multiply it times 0.7, and then I'm going to add 20. Now, I'm going to use the calculator's ability to use recursion to do this very quickly. So the next value should be 43.8, and it is, because I'm doing the same thing. Now all I have to do, I've got a model for the calculator to use, and I can see that if I do this and I just hit enter, it'll give me all of the answers I need. So 43.8 is the third day. 50.66, or rounded up as 50.7, is the fourth day. 55.5, I rounded up. 58.8, 61.2, 62.8, 64, and 64.8. Okay, so over the course of 10 days, notice that it keeps going up, but I need to keep going and check and see what it does in the next 10 days. So I'm going to go day 11, 65.3, 65.7, 66, 66.2, 66.4, 66.4, 66.5. You start to see a pattern. It's rounding up to 66.6. And as you can see, if I were to keep going past this, I'm at day 20. If I were to keep going past day 20, notice that all the numbers are turning to sixes. And you know why that is? Because the maximal dose, if we were actually to continue taking that 20 milligrams every day, our max dose, our max prescription, what we need, that main level we need to be at is 66.6. So every day we take another 20 milligrams, it'll bring us up to that level. Okay? So that's something we needed to notice in this particular project, or in this particular example. I think it's going to show all of the missing. It's okay, no biggie. We just went through it all. I showed you how I got it. You should be able to do that. What value does the amount of sneeze be gone in the bloodstream level off? It levels off at 66.6 in about 18 days. What type of function could model the amount of sneeze be gone in the bloodstream as a function of time? And explain your choice. Exponential decay. That's true because the amount that's coming off is decaying. But we're adding a little bit every time, so it's a piecewise decay function. What would you expect the graph of the amount of sneeze be gone in the bloodstream as a function of time to look like? And explain your prediction. So here's what I want you to understand. So you're going to start 20 milligrams, and it's going to slowly reduce in a decaying form. And then you're going to add 20 milligrams, it's going to go up, and it's going to do the same thing. Then you add 20 milligrams, it's going to go up, and you'll see what it looks like. There's the first day. There's the second day, third day, fourth day, fifth day, and so on. The general form of the exponential decay is y equals a times b raised to the x power, where a represents the starting amount of the substance and b represents the rate of decay. For a 20 milligram dose and a 30% flush rate, what exponential function could describe the amount of sneeze be gone in the bloodstream? As a function of y, function in the bloodstream, y is a function of time x. And don't forget that b represents the percent of sneeze be gone that remains in the bloodstream. So when we're talking about concentration, B at a 30% decay, we're going to multiply the initial amount that day of times the remainder. If 30% is gone, 70% is left. So yes, 20 times 0.7 raised to that power. How does that account for the additional 20 milligrams added to the concentration with the daily dose? It doesn't. Since the patient did not begin taking the medicine until day 1, we're going to adjust your function rule by subtracting 1 from your exponent and graph the function on your graphing calculator. So let's look and see what this looks like. If time x is given in terms of the number of days, what happens to the amount of sneeze be gone in the patient's bloodstream at the start of day 2 when the patient takes the second 20 milligram pill. And how does that affect the graph? And as you can see, the statement is the amount increases by the new dose, or 20 milligrams, causes a vertical shift or jump in the graph at day 2, suggesting the need for a step function style graph, or in this case, what we call a piecewise function. So here's how you would do it. We can use domain restrictions TI-84 plus to reflect the actual concentration of medicine. Enter this into Y1. Y1 equals 20 times 0.7 raised to the x minus 1. And then you'll put in parentheses these little x's greater than or equal to 1, parentheses, x is less than 2. And you'll open the window to x min equals 0, x max equals 8, and y min equals 0, and y max equals 70. This action, the function referred to here is actually y equals 20 times 0.7 x to the minus 1, where 1 is less than or equal to x, which is less than 2. And I'm going to show you what that looks like on the calculator. So I'm going to do exactly what I told you to do in this thing. I'm going to go to y equals, and I'm going to put 20 times 0.7 raised, raised to the x minus 1. Now, in order to do that, I have to put an x right here, x minus subtract 1. All right. Now, I'm going to come down off the caret by hitting an arrow over, and then I have to put these in parentheses, where x, and this is x, okay? Now, I have to put the greater than or equal to, so that's math function. You're going to have to go in here to where it says math. You're going to go second math, which is right here, which is the test, and you'll find your logic or test functions. So it's going to be greater than or equal to, which is 4. You'll hit enter, and then you'll put 1. Close parentheses, okay? Then you're also going to put another domain restriction, x is less than 2. So x, second math again, and you're going to go down till you get to 5, which is less than. Hit enter, that'll place it in there, and then 2, and close parentheses. Now you want to make sure that when you're done doing that, entering this in there, you have to open your window. And you see when you hit window, right here, you have all these minimum and maximum. So you're going to lose your minimum to 0, or reduce your minimum to 0 from -10. Reduce your maximum to 8 from 10. You're going to reduce your minimum y to 0 and your maximum y to 70. Now when you hit that graph, you'll see it better. Okay, so you see that little portion that it is. Okay, the function actually, it refers to 20.7, where 1, it's only between 1 and 2. Okay, it's only between 1 and 2. All right, and we can continue this on the next function. So this, now we're going to add the second part of the function by putting in y equals 2. Notice that the second one is 34, and it's also times 0.7, and it'll be raised to the x minus 2, because now it's not x minus 1, x minus 2, and we'll put in our domain functions from 1 to 2, or 2 to 3, I'm sorry. X, second math, 4, 2, and then x, second math, 5. You see how easy it is to put in there now. When you graph it, now it's going to show the second part too, a different color. Okay? And we can continue this through the whole thing, and as you can see, now we should have exactly what's shown on the screen. And I want to show you something. Notice that in the screen, it has arrows going on a curve to the maximum amount and the minimum amount. And we can actually determine what the double curve is created, but seems to be getting more and more horizontal as time goes on. And if you were to continue this, you'll see that it actually does. Assume the patient takes 20 milligrams of Sneeze Be Gone every day. And if you extend the graph on for another day 20, past day 20, what would be the minimum amount of Sneeze Be Gone in the bloodstream and what would be the maximum? Well, if you're adding 20 every day and you're getting to the maximum of 66.6, the minimum would be 20 from that, because you're going to get to that every time. So that ends up being 66.6, and the graph becomes a horizontal line. 46.6 would be the minimum. Launch you with this, folks. Make sure that you go and take care of your assignments. They are in Schoology. Appreciate your time. Folks, be blessed. Be a blessing.